Good evening, ladies and gentlemen, and welcome to today's class. We are going to have a conversation just around two major concepts. One, we will be talking about network design very briefly, network design. And in terms of network design, we are going to have just a basic conversation around the how to scale the network. Okay, and so we'll talk about a bit of convergence of voice, video, and data traffic. We'll explain the considerations for designing a scalable network, and then we'll look at the switch hardware requirements and router hardware requirements for small to medium sized business networks. And so let's get done here. Now, to start us off, let's look at what is called hierarchical networks. Now, you know that the current networks, companies, organizations, they are increasingly depending on the network infrastructure to provide mission critical services. And they require the network to be very scalable and to support so many things. Among them is converged network traffic, some critical applications like voice over IP, video conferencing and all that, business needs, and they require some centralized administrative control of their networks. And so most campus networks will always use a single LAN switch, and they keep on growing until they become larger and larger networks with thousands of end devices. And so it's important to talk about hierarchical networks. How can we have a network that has hierarchies? And talking about hierarchies within a network, a hierarchical network will always have either 2 or 3 layers. And the layers is access layer, distribution layer, and the core layer. Okay, and each layer always performing a specific function. So we have 2 types of network hierarchies, and the first one is a 3-tier network, and the other one is a 2-tier network. So let's start by having a conversation around the 2-tier network. So the 3-tier network. So the 3-tier network is a network that has the 3 layers of hierarchies. We have the lowest layer here. It's called the access layer. Mostly this is where we find layer 2 switches. We have access points. And most importantly, this is the layer that houses all the end devices. Very important. Okay. So the access layer, you don't find the end devices in any other layer apart from the access layer. And then we have the distribution layer, and then we have the core layer. The core layer is the highest layer. And of course, we are going to talk much about those layers. So most organizations that implement this 3-tier are mostly those organizations which have enough infrastructure, because you must purchase a separate devices for the core layer. You must purchase separate devices for the distribution layer. And of course, most of the distribution layer will be layer 3 switches. And the core layer, we have, of course, routers here, firewalls, and all that. So organization with enough resources will always go for the 3-tier. But if an organization does not have enough resources, then they will go for the 2-tier. Now, in 2-tier, what happens is that these are organizations without enough resources. And so what they do is that they combine the core and the distribution layer, and they only buy one set of devices to service those two layers. Okay. So they combine the core and distribution layer, but the access layer remains to be access layer. So that is two-tier, only two layers. The collapse core and distribution layer, and then the access layer only. Now, let's talk about the function of each of those layers. So the access layer, like we mentioned, provides network access to the end users, end devices, okay? That is the major function of the access layer. But the access layer switches will obviously connect now to the distribution layer switches. Now, talking about the distribution layer switches, they implement so many services, including routing, and of course, the running the dynamic routing protocols and static routing. There's quality of service within the distribution layer, and there's so much of security. Okay. Now, so routing, QoS, security are a major part of the distribution layer, and the aggregation here. And when we talk about aggregation, we are talking about things like ether channels. We're talking about some of these protocols, that help traffic to move faster from the from access layer to the core layer. Okay. And then finally, we have the core layer itself, which is always called the network backbone. Okay. And the reason why I call it the network backbone, because it connects all the several layers of the network. But majorly, it provides what is called fault isolation. Okay, because there's a lot of redundancy there, and it provides high-speed backbone connectivity. So fault isolation and high-speed backbone connectivity are some of the features of the core layer. Now, I want to have a conversation with you guys. What are some of the reasons why we have switches in a network? What is the role played by these switches in a network? The switches, they are very important. And the reason why we are talking about this is that it is true that a network can work without switches. That is actually very true. Okay. A network can actually do without switches. But a network cannot do without routers. But there are additional settings which is needed for a switch. Okay. So it is very, very important to understand that these switches play some very critical role in a system, and that's why we mostly find the switches very, very crucial part in our network. And you go to no network will you ever go to, and you find them not having switches. And that's why today we now go at the very bottom and look at what are some of the most important roles that the network will solve. The first one, there are additional flexibility that comes with switches. You know that a router normally has very few ports. Okay. Routers normally come with very, very few ports. And that's why we need to have switches as part and parcel of our network. So look at things like traffic management. And we are talking about things like VLANs. Okay. VLANs and trunks, they help us to really manage traffic. It could be traffic from different departments. It could be traffic from, different lands. And you just want to make sure that this track is being managed And you want to avoid situations like having to put everyone on just one single network. That is not one thing you really want to do. And that's why having switches in our network plays a critical role. Things like quality of service, things like security. You remember port security? Port security as a service is that which can only be normally configured on a switch. Look at devices like access points, which normally get their connections from a switch. Now, look at things like the voice over IP phones, okay? All these are devices that get their connections from a switch. And so it's very, very important for us to always have the services of a switch in our network. So again, look at the diagram we have here. This diagram has a couple of switches. And of course, it has the devices that we can be able to see here. And all those devices, you can see most of those end devices like printers, they get connection from a switch, okay? And you could put them in their own VLANs, so on and so forth, okay? Now, so moving forward, let's look at what a scalable network is, okay? I know that we have talked about the scalable network before, but I want us to just look at some of the methods that we can use to scale our networks. So we have redundancy, which is there. We have multiple links, that is Ether channels. We have scalable routing protocols, and OSPF plays a very critical role in that. We have wireless connectivity, which of course increases the access layer of our network. So let's talk about each of them one at a time. Now, looking at the, sorry guys for that, I have some small cold here. Blue. Now, when you have redundancy in your network, for example, looking at the diagram we have on our right-hand side here, we have S1, S2, S3, S4, S5, S6, 7, S8. You realize how traffic is crisscrossing this network, such that if switch S2 ever goes down, then traffic can still go through S6 and go to either S3 or go to S7. And even if it was S3 that went down, traffic will still be able to go to reach the server farm, the servers in the server farm, okay? And so redundancy, which basically means having multiple links or multiple devices within the network to be able to prevent what is called a single point of failure, okay? So have duplicate equipment or, providing extra links to be able to continue providing access within the network. The other way of ensuring scalability, of course, is increasing bandwidth between devices. And this is something we talked about in the topic called Ether channels, whereby you bundle physical links. Let's say each of this link is at, let's say, 1 Gbps, and this is also 1 Gbps. So we combine these links to work together to have a combined speed of 2 Gbps, okay? So if you can have a speed of 2 Gbps, so that traffic will not have to be traveling at individual links at 1 Gbps, but will travel at a double speed of 2 Gbps, any traffic coming from or coming from one of these switches to the other. So that is very, very important. And that is definitely something that we want to take care of. And by doing that, we are just increasing the link bandwidth between these two switches for faster transmission of our packets. Okay. Now, apart from increasing bandwidth, expanding the access layer of the network using wireless LANs, or what's called Wi-Fi, will help to increase flexibility, reduce the cost of accessing the network, and it will help the network to grow and adapt to some changing business needs. Okay. So when you have the wireless network in a network, then you know that some of the devices that only have wireless NIC, that are called wireless devices, they will be able to access internet, and we won't need to make devices to only have cable to access the internet or the network. Okay. And so wireless networks using access point and even using wireless routers is a very brilliant idea. And this, of course, comes with a mobility factor in it. Finally, scaling networks also needs us to use some dynamic routing protocols. And like I told you, OSPF, the Open Shortest Path First, is one of those protocols that can be used in very large networks. Why? Because the more the number of OSPF routers increase, OSPF can actually be divided into different areas. Okay, so you're gonna start with the area 0, then you can break up to area 1, area 2, 3, 4, 5, all the way to area 51. There are only two conditions. That one, when you have multi-area, all areas must be joined to area 0, which is the backbone area. And two, it's also important to note that the reason why we have this multi-area in OSPF is that when you have a network interference, or we have a network downtime in any of the areas, only the devices in that area will be affected. The devices out of those areas will not be affected in any way. So that is very, very important. Okay, a problem in one area affects only devices in that particular area. Now, I want us to have a conversation around some switch fabrics here, switching hardware. And like having talked about the impedance of a switch in the network, there are some form factors that always need to be considered before purchasing a laptop. And so, before purchasing a switch, okay? So there exist so many types of switches. Like this one is a campus LAN switch. This is a 3850 series switch. Normally has higher concentration of ports, and they come with different speeds and security settings. The first one up here is a Cisco Meraki. It's a cloud managed access switch that can also do virtual routing, virtual stacking of the switches. Okay, and here you can configure so many ports, thousands of ports just over the network, over the web, without any physical connection. So that is something important to note. Of course, we have the Cisco Nexus switch, also promotes infrastructure flexibility, and majorly used within data centers. Okay, so that is also very, very important. We have, of course, service provider switches. Yeah, these are switches that are used within ISPs, and they have so many features, including virtualization, application intelligence. They have integrated security within them, and for simplified management. Some of them are huge. Okay. Down here, of course, we're having the Cisco, the Nexus virtual networking switch. This provides a multi-tenant services, and it has some test of virtualization intelligence technology, and majorly used within data centers. Okay. Let's look at some form factors of switches. And these are very important, just for us to note. And it's important for us to know that switches come in different form factors. We have fixed switches that come with fixed features. We call them fixed configuration switches. We have switches that come with features that can be modified. We call them modular configuration switches. We have switches that can be bundled together. You know, you have like 4 or 5 switches. You can bundle them together to form one switch to work as one powerful switch. We call them stackable switches. And those switches which cannot be stuck together are called non-stackable switches. So the switches which can be combined together, they come with a special type of cable, which is normally is used to bundle these switches to work as one powerful switch. Okay. Now, this is a very good example of the stackable switches. You can see we have here 1, 2, 3, 4, 5, 6, 7, 8. 8 switches here using this special type of cabling have been bundled together, and they are now working as one powerful switch. Okay. Now, apart from these stackable switches, of course, we have what is called port density. And port density is just the number of ports that a switch has. And different switches support different types of ports. Like we have switches with 12 ports, 24 ports, switches with 48 ports, and we have switches that can support up to even 384 ports. Those are very, very large ports. And we have switches that can support even up to 1,000 ports. So it's definitely a variation between switches. Now, switches also come with different forwarding rates or speeds. And this one is majorly on their interfaces, okay? So that's how much data the switch can process per second. And the speed interfaces range from 10 Mbps to 100 Mbps, okay? To 1 Gbps to 10 Gbps, all the way up to 100 Gbps, okay? Now, we need to also therefore note that access layer switches, they don't need to operate at their full wire speed. And basically this is because they normally are physically limited, but they are uplinks to the distribution layer switches. So that is, again, very, very important for us to be noting. Now, some switches have a special feature called the PoE, okay? And these switches help to power devices like IP phones, access points, the cameras, web cameras, okay? And so what happens is that not all switches, but some switches have a feature called power over Ethernet or PoE, okay? And so this PoE port delivers power through the same port that it delivers the Ethernet frames, okay? And so these devices I'm mentioning, normally they don't have their own power cords or power devices, okay? But what happens is that they are able to get power from the switch, and the switch must be having those particular ports. Now, it's also important to note that switches with this particular feature tend to be a bit expensive than those without PoE devices. You must have heard of multi-layered switches, and the multi-layered switches normally are normally deployed at either at the core or at the distribution layer of the organization's network. And they have the ability to support routing protocols and packet forwarding of IP packet, just like a router does. Of course, just like a switch does. So the layer 3 switches support a feature called ASICs, the application-specific integrated circuits, which is a hardware. Okay. Now, the ASICs, along with some other dedicated software structure, they streamline the forwarding of IP packets, and this is very independent of the CPU. Don't engage the CPU a lot, and that's why layer 3 switches are faster, very, very fast. Now, so part of those considerations when put together here will give you the considerations when you need to select a good switch, and that will depend on so many factors. And some of those factors are listed here. Of course, your budget is very important. How much budget do you have for this particular purchase of your switches? And the cost here will depend on the number of ports, the amount of speed or the speed of the ports, some other supported features like PoE, and any kind of support expansion capabilities. We also have what's called the port density. I've talked about it. Switches, of course, with the higher the number of ports, the more it will cost of this the switch. Switches that come with PoE are more expensive because they can provide power as well as connectivity to access points, IP phones, and even cameras. In terms of reliability, you need a switch that gives you a continuous access to your network resources, and that is important. Of course, the higher the port speeds, the more expensive the switches will cost. Switches also come with what's called a buffer memory, which is a temporary storage for frames as they are being processed by the switch before they can be sent out of the interfaces. And so switches with larger buffer memories will cost more than switches with smaller buffer memories. Now, switches which can provide a higher growth, that is switches with either more ports or switches that can be extended. Okay, we can expand their functionalities, will obviously cost you more. Now, let's now talk about the router hardware. And talking about the router hardware, the router is one of the most important devices in the network, okay? And that's simply because they have the ability to select the destination path if the current path goes down. And all the host devices on the network, they must be configured with the IP address of the local router interface, because that will act as their default gateway. Routers provide broadcast containment, like I had mentioned before. Routers do not forward any broadcast out of from a LAN to another network. Routers interconnect very geographical separated locations, and makes them to just work as one network. Routers can also group users. Okay, routers can group users logically, and this has something to do with what we call router on a stick intervalent routing, and that's very important. Routers can also be configured with access control lists, and that provide security within the network. So that is very important. So different form factors for routers. We have branch routers. A very good example is the 4000 series routers. These ones could be used within the branch networks or within one infrastructures. We have the network edge routers. A good example is the ASR, the aggregation services routers. Okay, the 9000 series. They deliver very high performance and high secure and reliable campus network within data centers and even within branch networks. We have ISP or service provider routers. A very good example is the network convergence systems. They deliver end-to-end scalable solutions and subscriber-aware services. And the 6000 series, the NCS, the network convergence system routers, it also comes with an open door that you can close. You don't need to buy a cabinet. We have routers that are used within the industrial areas. We have routers that are used within industrial areas. Okay. And these routers are always found in very rugged places and harsh environments. Okay. Like in an industry, a manufacturing industry, or within the forest or something like that. They are very tough devices. A very good example is the industrial integrated services routers, like the 1100 series. So we want to look at each and every of those routers. This, the 900 series router we saw there, combines a wider network connectivity, switching, security, and advanced options. This type of router doesn't have a fan; it's fanless, and it's also small in size. Of course, we have the service provider routers. Okay, we have those ones that we always use, and the 9000 and 1000 aggregation services routers are a very good example. Provide great density of the ports, resilience with some kind of programmability, and very scalable devices as well. So that is that. For the uh, uh, still part of the form factors, we have the network convergence systems, the 5500 series. These are routers built for data centers and very large enterprise networks, including web servers, mail servers, so on and so forth. Of course, we have the industrial integrated service routers, the 800 series. These are very well meant for the harsh environments, and they survive there and still provide very, very good connectivity within them. Okay, so moving forward, ladies and gentlemen, I now want us to have a very important conversation, and this is going to be, of course, this is the end of this part here for network design. Now, what I want us to do now, even having talked about network design, is that I want us to